Hello everyone, this is Dr. E, and for today we're going to learn how to classify polygons in geometry. There are different ways on how we name and classify polygons, and that's what we're going to be working on in our lesson for today. So first, let's define what polygon is in geometry. Polygon, it is a figure, or a figure is a polygon if it meets the following conditions. And we need to know these conditions so that we'll be able to understand that that particular shape or figure that we are seeing is indeed considered as a polygon. So one, it is a plane figure formed by three or more line segments called sides. Two, sides that have a common endpoint are non-collinear. And three, each side intersects exactly two other sides, but only at their endpoints. And these are the three conditions that we need to satisfy for us to know that the shape or figure we are seeing are polygons. So let's have examples of those shapes and figures, and let's identify which one is considered to be a polygon. Now, the next thing that we need to know is how we name polygons. Just like in any other shapes or figures in geometry, like angles or figures, we name these figures using notations. And we need to know these methods so that we'll be able to learn how to write and how to understand symbols and notations in geometry. Now, the endpoints of the sides of a polygon are called the vertices. That is the plural form, and the singular form is called the vertex. Now, a polygon can be named by listing its vertices consecutively in order. Operative word is order, which means if we're going to look at example number 2, we are seeing 1, 2, 3, 4, 5, five-sided polygon, and this is a polygon because it satisfies the three conditions, and we're going to learn how to name this polygon since each vertex has its corresponding letters. So we can name this as polygon E, D, H, G, F. And we can call it as E, D, H, E, F because we started with E and then D and then H and then G and then F. And if we're going to do it the other way around, we can also name it as E, F, G, H, D. Both of them are valid names for this five-sided polygon. However, if we name this as D, E, H, F, G, which is just randomly picking numbers from our vertices, this is not a valid name for our polygon because that's not how we name our polygons. So keep that in mind. You need to know your names or how you name your polygons, and two, you need to know the conditions for your shapes to be called a polygon. So we can name this as ADHGF, and I'm sure that you can name you can think of other names for this polygon using this rule. Now, let's proceed to these examples, and we're seeing 5 different shapes. Not all of them are considered polygon, so we're going to be identifying which among the 5 shapes that we're seeing can be considered as a polygon. And you need to tell me why it's not a polygon if you think that it defies the 3 conditions that we have. So by just looking at our 5 examples, we know easily that the first one is a polygon, and the last one is a polygon. So we only have 2 polygons in these examples. Just to be clear that not all figures and shapes in geometry can be called as polygon. Why can't we call B a polygon? Because this semicircle, according to our reason, figure B is not a polygon because there is a side that is a curve and not a line segment. So if you are seeing curvature in any of your shapes, it's not a polygon anymore. So a circle, an ellipse, and a semicircle is not considered as a polygon. What about letter C? Letter C is also not a polygon because by our definition, there is a side that intersects more than two other sides. And that is this side right here that we are seeing. And you can also tell that with this side, you can form two or more polygons if we separate them. So when that happens, you know that this is not a polygon. So keep that in mind. Anything that has this line inside your polygon will not make it be classified as a polygon. And letter D, what is wrong with letter D? It is also clear that this is somehow incomplete and we have an opening in this side of our polygon, and that is another reason to say that D is not a polygon. Figure D is not a polygon because two sides intersects only one other side. And in this case, it did not happen because there is a break on your top part of your shape. I cannot say polygon because this is not a polygon. So that's how we classify figures or shapes if it's a polygon. Now, let's learn how to name our polygons. So we have special names according to the number of sides of our polygons, and we will start with these list of names that we have. There's only a finite set of names that we have, and it's all the way to 12-side or 12-sided polygon. So if you're seeing a 3-sided polygon, we name it as a triangle, which is pretty popular. We all know that a 3-sided polygon is a triangle. So 1, 2, 3, no matter what the type of this triangle is, we know it's a triangle because there's 1, 2, 3 sides in our polygon. We can say that it's a quadrilateral, 1, 2, 3, 4, because okay, let's close it so that we know that it's a proper polygon. So this is a quadrilateral because we have 1, 2, 3, 4 sides in this particular shape. And the number of sides or the name of your polygon is dependent on your number of sides. And notice that we only have up until 12-sided polygon that has its special names. And that is the only way you can name these polygons, because anything that is higher than 12, let's say a 13-sided polygon or 28-sided polygon or a 100-sided polygon, we'll just name it as 100gon. And that is how we name these polygons. So in general, a polygon with n side is called an n-gon. And if we have a 13-sided polygon, we can call it as a 13gon. Now, if we have a 3-sided polygon, which is a triangle, can we also name it as a 3gon? Of course we can, because the general rule in naming a polygon is just count the number of sides and put a gon after it. But of course, this is mathematics and this is geometry. We need to be more specific, and let's use their special names just like what we have on the previous list. Now, another way of classifying polygons will be according to its types, and we have convex and concave polygons. How do we know if a polygon is considered as convex, and how do we know if it's considered as concave? By the definition, a polygon is convex if no line containing a side contains a point within the interior of a polygon. That is a convex polygon. And concave polygon, a polygon is concave if it's not convex, which is pretty confusing still. But if we have more examples or concrete example, I'm pretty sure that you will remember and you would know how to classify if a polygon is a convex, concave, or convex. So the first one, this is a 1, 2, 3, 4, 5, 6, 7, 8. This is an 8-sided polygon, which is an octagon. This one, is this concave or convex? This one is a convex polygon. It's convex because I will give you my technique on how I will identify, or I identify a convex polygon easily. Letter B, is this convex or concave? B is concave polygon. And it's concave because if you are seeing it, there is a dent coming in to your polygon, and that's why it's called concave. But I'm going to give you another way or trick on how to identify concave polygon. And if you can differentiate it now, I'm pretty sure most of you can tell me if C is a convex and a concave polygon, because C, as we all know, is a convex polygon. Now, how do we identify convex and concave polygon? So for example, we have this polygon. Is this concave or convex? And this polygon, is this concave or convex? And to be able to identify this, I always show my students a special video game in the 80s called Pac-Man, and Pac-Man looks like this. This is Pac-Man, and there's also Mrs. Pac-Man. And if you can produce a Pac-Man or Mrs. Pac-Man in your angles, in your polygon, then it will be a concave polygon. And how do we produce that? Just look at your figure. If in your angles, and you draw a curve in your angle, and if you see a Pac-Man there, then you know it's concave. And obviously, there's no Pac-Man in a triangle, so this one is a convex polygon. And for this one, I can spot one right here. Now we know that this is a concave polygon because we're able to spot the Pac-Man in our polygon. So that's one trick that you can use. Find the Pac-Man in your polygon, and if you see a Pac-Man in your polygon, then it is a concave polygon. So that's what you can use. It's not scientific method, but it works. So whatever works, if you can come up with your own way, comment it down below and let me know how you can differentiate a concave and a convex polygon using your own method. And another types of polygons that we can classify polygons with is that if it's a regular or non-regular polygon. And how do we identify regular and non-regular polygon? We have 3 examples right here in our slides. And for letter A, we're noticing that this polygon has a special marking. And in their angles, they only have one curvature or one single curve. And for its sides, there's also one marking. So that means letter A, it's both equilateral and equiangular. And equilateral means their lengths are all congruent. And equiangular because all their angles are congruent. So this angle and this angle are congruent, and the rest of the angles here have the same measurement because of this marking. It goes with their sides as well. Now, with that in mind, if A is a regular, because it's equiangular and also equilateral, is B a regular polygon? And we know, based on our example letter A, that B is not a regular polygon because it may be equilateral because their markings on the sides are all the same or congruent, but their angles don't have the same measurements. And we would know that because we already know that this one is an obtuse angle and this one is an acute angle. So we know that this is not a regular polygon because it's not equiangular. And for letter C, can we say that C is irregular because we're seeing congruent angles and congruent sides? Sides, yes, but on their angles, these opposite angles are congruent, these opposite angles are congruent, but this corner and this corner, they're no longer congruent because this is an acute angle, this is an obtuse angle. So that means letter C is not a regular polygon. So that's how quick we can identify polygons that are regular and maybe even convex. So can we do that? Of course. Letter A, there's no Pac-Man in the angles. For letter B, I'm sure you can spot your Pac-Man for letter B. And for letter C, you will also not be able to produce a Pac-Man on letter C. So that means only B is considered as concave and A and C are both convex polygon. And those are the types of polygons that we can classify it with. And if we're looking at A, B, C, we know that A is convex, B is concave, and C is convex. But can we say that A is a regular polygon? And the answer is no. And why is it A no, because even though it looks like their angles and their sides are all congruent, but there's no special markings that will indicate that they have congruent sides and congruent angles. So we need to be careful because we cannot just judge a polygon by its cover. No, we cannot just judge a polygon without any markings in geometry, because we need to know that it's important. Marks and notations in mathematics, they are all important. So we can only say that they're concave and convex, but we really cannot identify regular polygons for A, B, and C because there's not enough information to verify that type of polygon. So with that, your number bender challenge of the day is to tell me what type of polygon this shape you're seeing right now. And let's even make it more advanced by telling me if it's a regular polygon or not regular polygon, and if this is a concave or convex polygon. Comment it down below and tell me the reason why you named this polygon as such. And this is our lesson on geometry on polygons. So make sure that you will remember how you will name your polygons according to its number of sides, and how you classify your polygons according to its, if it's convex or concave, or if it's regular or not regular polygon. This is Dr. E, and see you again next time. Bye!